the questions?
Yes, sir.
The notes? Was the notes forwarded for the 3 units?
Yes, sir.
Okay. So today, let us discuss some question bank. Okay. So let us discuss question bank questions. If you feel any difficulty, then you can ask me immediately so that we can get it clear. Okay.
Okay, sir.
Right. See, I'm sharing you the screen. So let us start from module 1. Okay. So the first question is, calculate the velocity and kinetic energy of electron having wavelength of 0.21 nanometers. Okay. I think this question was readily discussed in the class. Am I right?
Yes, sir.
Right. So velocity is V is equals to lambda by h under root of 2 h in v. So based on that, we have to derive the expression. We have to go for the calculation and do that. So the next question, determine the de Broglie wavelength associated with the proton moving with a velocity of 1 by 10 of velocity of light. I think this question is also discussed in the class. Was it noted by you all? Was it noted by you all?
No, sir.
No, sir.
Determine
Yes, sir. We wrote it.
Yeah, so determine the de Broglie wavelength associated with the proton moving with a velocity of 1 by 10 of velocity of light.
Yes, sir. We wrote.
So this question was discussed in the class. So do you want me to show again that the question?
Yes, sir.
Okay. So next question is, estimate the wavelength of an electron rose to potential of 15 kilovolt. I think this question is also discussed. Estimate the wavelength of electron, lambda equals to 1 by lambda equals to h by under root
Yes, sir.
EV. So this is the formula what you have to use it and determine the wavelength. You have to determine the value of wavelength. Okay, that is lambda. Okay. So next question, fourth question, obtain de Broglie wavelength of neutron. The kinetic energy of the neutron is 0.025 electron volt and mass of neutron is 1.674 into 10 power minus 27 kg. So, okay. So that is your de Broglie wavelength. The same expression you have to use. So lambda equals to h by under root 2 MeV.
This also we wrote, sir.
Okay, these all questions I think we have discussed in the class. Okay. So
Only 4 questions, sir.
only 4 questions.
Yes, sir.
So did we not discuss this question? Calculate the wavelength of a proton.
No, sir.
Kinetic energy of the proton is 500 electron volt. So the same ade kadamma, the calculate the wavelength of a proton, lambda equals to h by under root 2 ME. Same expression we have to follow it. Okay.
Okay.
So sixth question also the same. So seventh question, calculate the energies that can be possessed by a particle of mass 8.50 into 10 power minus 31 kg, which is placed in a infinite potential box of width 10 power minus 9 meters. So for this you have to use the expression. That is for this question you have to use the expression E equals to n square h square by 8ml square. Am I right? You find this relation somewhere? Did you find this relation that is E is equals to n square h square by 8ml square? So that is what calculate the energies that can be possessed by a particle of mass, okay, by particle of mass 8.50 to 10 power minus 31 kg, which is placed in infinite potential box, okay, of width 10 power minus 9 meters. Okay, you take n equals to 1. Is that clear? Was that question okay?
Yes, sir.
So the next question also, find the lowest energy of an electron confined in a square box of width 0.4 nanometers. Lowest energy is n equals to 1. Okay. So next question is, electrons are accelerated by 344 volts and are reflected from a crystal. The first reflection occurs when the glancing angle is 60 degrees. Okay, determine the spacing of the crystal. Determine the spacing of the crystal. For this question, you have to use the X-ray diffractometer, that is 2D sin theta. The expression for the X-ray diffractometer is 2D sin theta is equals to what?
N lambda.
Very good. Is equals to n lambda. Okay. So what is asked to find? You have to find the first diffraction occurs when the glancing angle is 60 degrees. Determine the spacing of the crystal. Sir, class lo unnam sir. Awesome, sir. Awesome. Okay, electrons are accelerated by 344 volts and are reflected from a crystal. The first reflection maximum occurs when the glancing angle is 60 degrees. Determine the spacing of the crystal. That is what you have to use the expression dt is equals to n lambda. Okay, so where we have to first find the lambda value and then you have to find the d. Okay, so d is equals to d is equals to n lambda by 2 sin theta. N lambda by 2 sin theta. This is your expression d value. Okay. So next question is, an electron is bound in one-dimensional infinite potential well of width 1 into 10 power minus 18 meters. Find the energies in the ground state and the first two excited states. Okay. So find the electron is bound to one-dimensional potential well of width 1 into 10 power minus 10 meters. Find the energy levels in the ground state. Ground state means En. Okay, En equals to 1. And at the same time, first two excited states. So in E2, say light. And then you have to take E2 minus E1. Okay, with this width, electron is there. So you have to take the mass of the electron. Okay, so H is a Planck's constant, L is given, and you have to find the energies. Ground state and E is equals to E at n equals to 1 ground state and at the grounds at the next excited state, that is E2. If you want, you can find energy difference also, E2 minus E1. Makes no difference, just you see it if it is possible. Okay, clear?
Yes.
Yes. So the next question is, so next let us go for long answer questions. Compare a particle with a wave and discuss about dual nature of radiation. Okay, so compare a particle with wave and discuss about dual nature of radiation. So you have to explain the dual nature. Okay, dual nature of matter wave. Okay, you have to explain the dual nature. So I think that it is there in the notes. Okay, so wave particle duality you have to explain here. Okay, is that clear?
Yes, sir.
So next is explain the physical significance of wave function according to Schrodinger and Max Born interpretation. Right. So you have to explain the physical significance of psi. So after you explain the physical significance of psi, try to interpret it the Max Born approximation, that is triple integral psi square dx dy dz equals to 1. That is what the normalization condition you have to prove it. Normalization condition has to be proved there. Okay. Is that okay? Max Born interpretation is nothing but the normalization condition. You have to explain the physical significance of the wave function. Okay, na?
Yes,
Yes,
sir.
sir.
Next, matter waves are new kind of waves. Justify the concept by discussing different properties of matter waves. We have discussed some properties of matter waves. Am I right? What are the properties of matter waves? Anybody? What are properties of matter waves?
Greater is the wavelength, lower is the de Broglie wavelength.
Inka? Any more?
Smaller is the velocity, greater is the wavelength.
Okay. Any more?
When V is equal to 0, lambda is infinity, and V is equal to infinity, lambda is 0.
Okay. So, properties.
And no single phenomena can exhibit both the particle nature and wave nature simultaneously.
So, properties so those properties you need to explain. Okay. Can you see? I am sharing the notes also. I'm showing you some notes also. Is it visible on the screen?
Yes, sir.
So see here, physical significance of psi. The actual meaning of psi is not clear. So Max Born interpretation psi is given in 1926 and generally accepted as present. So as psi is a complex function, psi into psi is equal to psi star is a real value. Nor psi square at a point is proportional to the probability of finding the particle at that point at any given instant. The probability density at any point is represented by mod of psi square. The probability P of finding the particle within any element of volume dx, dy, dz is given by this one. So since the total probability of finding the particle somewhere is unity, psi is a such function that satisfies the condition mod of psi square dx, dy, dz equals to 1. Psi satisfying the above condition is called the normalized function. Besides this, psi is a single valued continuous function. Okay, so this is what the Born interpretation you have to do it. Okay. So that is the one. So next, using Planck's and Einstein's theory of radiation, show that the wavelength associated with an electron of mass m and kinetic energy is given by E is equals to h by under root 2 me. So this is what the derivation you have to do it. I think we have did it. Okay, you want me to show? So this is what the expression we have to do it. See here. Can you see?
Yes, sir.
So this is what VPH, this is what lambda equals to h by root 2 mqv. So this is obtained by taking that is what E is equals to mg square is equal to lambda. So this is the expression for de Broglie wavelength. Lambda is equals to h by under root 2 me. So this is the expression what you have to determine. Okay. So that is what use Planck's Einstein theory of radiation show that wavelength associated with electron of mass m and kinetic energy is given by h by under root 2 mev, right? So that is the expression. Next is determine an expression for the wavelength associated with an electron accelerated by potential v. Okay, so this is also one more important question. Okay, so the same question is interlinked with that, right? So the next question is why matter waves are observed only for particles of atomic or nuclear size and not for particles of heavier mass? So what the answer you would write for this? What is the answer you are going to write for this question? What is the answer? Why matter waves are observed only for particles of atomic or nuclear mass and not for particles of heavier mass? Why? What is the question? What is the answer? What you have to write? Why matter waves are observed only for particles of atomic or nuclear size and not for the particles of heavier mass? This question answer em rastam. Em rastam andi? Why matter waves are observed only for particles of atomic or nuclear size and not for particles of heavier mass? నోట్స్ చూసుకున్నారా? క్లాస్లో చెప్పింది ఇప్పుడు మొన్న పంపించిన నోట్స్ ఒకసారి చెక్ చేసుకున్నారా? మా క్లాస్లో పంపించింది ఇప్పుడు నోట్స్ రెండు చెక్ చేసుకున్నారా? చెప్పండి. So what are the properties of matter waves? You write. What are the properties of matter waves? You write. De Broglie's hypothesis.
Matter waves can travel with a velocity greater than the velocity of light.
So waves and particles. Have you found the difference? Waves and particle. The concept of particle is easy to grasp. It has mass. It is located at some point. It can move from another point, specified by some parameters. Wave is also having some parameters. And then we went for wave particle duality of radiation. Okay. చెప్పండి. చెప్పాలి. Matter waves, according to de Broglie, the matter particle like neutron, like electron or neutron is pictured as a group of waves. These waves are called the matter waves or de Broglie waves. Every moving particle associated with a wave called de Broglie wave. Properties of matter waves, that is wavelength. సో ఈ పాయింట్ నుంచి మీకు ఆన్సర్ దొరుకుతుంది. దాని నుంచి మీరు అనలైజ్ చేసుకొని రాయాలి. ఓకే, ఓకేనా? రాస్తారా? రాయగలుగుతారా?
సార్ 6th క్వశ్చన్ కి ఏం రాయాలి సార్?
అదే చెప్తున్నాం కదమ్మా. Why matter waves are observed only for particles of atomic or nuclear size and not for particles of heavier mass. Matter waves, what are the properties of matter waves? ఇప్పుడు చెప్పింది అదే కదా.
ప్రాపర్టీస్ రాయాలి సార్.
ప్రాపర్టీస్ రాసి దాన్ని కొంచెం రిలేట్ చేయండి. ఓకే, వేవ్ పార్టికల్ డ్యూయాలిటీకి కొంచెం రిలేట్ చేయండి. ఓకే, వేవ్ అంటే రాయండి. ఫస్ట్ పార్టికల్స్ ఏంటి రాయండి, పార్టికల్ పారామీటర్స్ రాయండి, అవి వేవ్ కి రిలేట్ చేయండి. రిలేట్ చేసి హైపోథసిస్ కి ఎట్లాగా ఇచ్చేస్తారో చెప్పండి ఇక్కడ. సో దస్ పీరియడ్స్ ఎలక్ట్రాన్ మోడ్ ఈజ్ కంక్లూడ్ de Broglie wavelength అని చెప్పి రాయాలి. ఓకే, ఇట్ హ్యాస్ మాస్ ఫీచర్స్ గురించి మాట్లాడుకున్నాం కదా. ఓకే, నెక్స్ట్ explain the difference between a matter wave and an electromagnetic wave. So this question answer also we have written in the class, and this is related to this 6th question. 7th question is also, some of the points of 7th question is also related to 6th question. Okay, some points of 7th question is also related to 6th question. So 6th and 7th can be interrelated. Okay, okay na?
Okay sir.
Next question.
Yes.
Yeah, next question. Describe Davison-Germer experiment with a neat diagram and explain how it established the proof of wave nature of electrons. Okay, so the Davison-Germer experiment తెలుసు కదా మనకి. Davison-Germer experiment తెలుసు కదా, నికెల్ టార్గెట్ నుంచి ఎలక్ట్రాన్స్ ఎమిట్ అయితే.
Yes sir.
Okay, so that experimental verification you have to draw it. Okay, you have to draw it and try to explain with some proof. Okay, so this is an experimental verification for matter waves. Okay, experimental verification for matter waves, and we have to matter waves ki experimental verification in terms of particle తీసుకొని దానికి correlate చేసి experimental verification ఉందని చెప్పాడు కదా. So that is what the de Broglie, that is what the Davison-Germer experiment. So next, considering the dual nature of electron, derive Schrödinger's time independent wave equation for the motion of an electron. So that is what you have to derive. Del square psi plus 2m by h bar square into e minus v into psi equals to 0. So that is what the expression you have to derive it. Okay, so that is the 9th question. So it is directly there in the notes which I have given you. Okay.
Yes sir.
Next question. Assuming that a particle of mass m is confined in a free region between impenetrable walls in infinite height at x equals to 0 and x equals to a, show that the energy levels are quantized. So that is E equals to n square h square by 8m a square. Okay, that is what you have to derive the expression for particle in a box. You have to derive the expression for particle in a
box.
Particle in a box. So that is the question there. Next. So 11th question. Discuss the results from the eigenvalues and eigenfunctions and probability density for a particle in one-dimensional potential box of infinite height. Also sketch the figures. Yeah. So discuss the results from the eigenvalues and eigenfunctions. So we did not discuss about the eigenvalue and eigenfunctions. Okay. So this I will try to show you in the figure. Just to go through that. See here. So see here. Okay. So the wave functions corresponding to energy levels of the particle shown are, this is what we have seen in our class, right?
Yes, sir.
So E1 equals to h square by 8ml square, E2 is equals to 4h square by 8ml square, and E3 equals to 9h square by 8ml square. So this is what the wave functions and probability densities. Okay. And three-dimensional, the three-dimensional case, that was a different 3 dimensions case. The Schrodinger equation, the Schrodinger wave and probability X was shown here. Okay. So now, right. Okay, so we will. I will let you know how to give eigenvalue and eigenfunction. Okay, I will let you know this expression later. Okay, don't worry. Okay.
Okay,
okay. So 11th question, you put a tick mark. Okay, so that we will discuss that in the class. Okay. We'll discuss in the class, or we will go ahead with if you can, let us complete all this, and then we'll discuss what is eigenvalue and eigenfunction. Okay. So next.
okay.
Show that the energies of a particle confined between two rigid walls of infinite potential are quantized. That is what the same question for 10th. 10th question is similar to 12th question. Okay. Okay. So next question. What are the de Broglie matter waves? Derive expression for de Broglie wavelengths associated with the particle having mass m and velocity v. So this is what de Broglie matter waves you have to derive the expression. Okay. Next question is obtain eigenvalues of energy. Obtain eigenvalues of energy and write the first three eigenfunctions to a particle in a box of side L. I'll tell you this eigenfunction, how to write the eigenfunction and eigenvalues. So based on this, we have to see here. Okay. I'll tell you how to write the eigenvalue and how to go for eigenfunction. Right. So write major differences between the classical mechanics and quantum mechanics. Okay, so this is a very, very fundamental question in the very beginning of the module, right? That is the first chapter. So what is the difference between classical mechanics and quantum mechanics? Classical mechanics and quantum mechanics differences ఏంటండి? Classical mechanics was failed somewhere where the quantum physics was existed, right? So you have to tell the differences between classical mechanics and quantum mechanics. Okay. Chepagaltara? Can you go ahead with this 15th question? Major difference ఏమున్నాయి classical physics ki quantum physics ki? Classical mechanics was failed to explain the stability of the atom, black body radiation, okay, photoelectric effect, Compton effect. So these drawbacks are achieved by whom? Quantum mechanics. Kada?
Yes, sir.
So differences రాయాలి మీరు. Okay, so differences మీకు module ఇచ్చానా? లేకపోతే I'll tell you again. I'll tell you this question also again. Yeah, somewhere here written it is. Yeah. See here. You will see the very first part. the quantum mechanics, Newtonian mechanics, Maxwell's electromagnetic theory, and thermodynamics guided the growth of science and engineering during the years spanning from 17th to 19th centuries. The above theories, which are successful in the realms of microscopic world, are regarded as classical physics. In classical physics, matter and fields are treated as entirely independent entities. Okay. So in general, if you sum up some assumptions of classical physics, are energy is continuous, position and momentum of particle can be determined exactly. If a charge oscillates with constant frequency nu, it produces an electromagnetic wave of same frequency. The energy of the wave is not related to the frequency of the wave. It is proportional to square of the amplitude. So classical physics fails to explain the stability of the atom, origin of discrete spectra of atoms, the spectrum of black body radiation, photoelectric effect. Okay. So photoelectric effect, black body effect, and all this. Okay. And then try to write some differences between the quantum physics and classical physics. You can have some differences on the very first part here. Okay. First ga chuste meeku dorukutadi differences, right?
Okay, sir.
Okay na, andaru note cheskuntunnara points?
Yes, sir.
So next, 16th question, differentiate between psi and psi star. What is psi? Psi is nothing but a wave function. What is mod of psi square? It is a conjugate, right? Mod of psi square is a complex conjugate of the wave function psi. Okay. So which was given by Max Born interpretation. That is what, if you need any guidance here also you can see learner to recall the characteristics of wave function and understand Max Born and Schrodinger interpretation of wave function. So psi is nothing but the physical, psi is nothing but the wave function. Okay, and mod of psi square is nothing but the conjugate of the wave function, which gives to the normalization. That is what Max Born interpretation. Okay, next, highlight the conditions for an acceptable wave function. Okay, so highlight the conditions for an acceptable wave function in the sense learners to recall the characteristics of wave function and understand the dual nature of material particle. So try to understand the dual nature of radiation. Okay, try to go for dual nature of radiation. Okay, so next, how do you predict the energy of a particle in closed box from classical theory and quantum theory? Classical theory and quantum theory పట్ల ఎట్లా మనం డిఫరెన్షియేట్ చేస్తాము అంటే చూడండి, so classical theory is given by like waves in stretched string. Okay, classical theory is given by waves in stretched string where we have some nodes and antinodes kada. అదే కదా.
Yes, sir.
Okay, so probability density is what you give the nomenclature for quantum mechanics. So that is what the answer you have to write it. So classical theory and quantum theory. So quantum theory prakaram manam koni features enunciate chestam like eigen value. Okay, I'll tell you, like eigen function. Okay, classical theory prakaram దాని యొక్క వేవ్ ఫంక్షన్ డిజైన్ చేస్తాం. ఇట్లా 2 పాయింట్స్ తీసుకున్నాం కదా, 2 పొజిషన్స్ తీసుకొని ఇది యాక్సిస్ అయితే, సో ఇక్కడ నుంచి ఇక్కడికి n equals to 1, n equals to 2, ఇంకోటి nodes, n equals to 1 node, n equals to 2 nodes. Like that we have found the differences. Okay, so that is what. So I'll tell you this question also clearly. Okay, I'll tell you this question also, 18th question also clearly. So 3 questions I'll let you know clearly. Okay, next is explain the concept of phase velocity and deduce the expression for phase velocity of matter wave. Okay, so this question is directly discussed. How do you determine the phase velocity and wave velocity? Am I right? Am I right? Phase velocity and wave velocity andi. Somewhere here you can write. Yes. Yes, see here. Each wave of the group of matter waves travel with a velocity known as wave velocity. is known as phase velocity of the wave. It is given by phase velocity. Vph is nothing but V phase. Velocity phase equals to omega by k, where omega is equals to 2 pi by, where omega equals to 2 pi nu, and k is equals to 2 pi by lambda. That is propagation constant. Okay, and omega is angular frequency. Therefore, we can write it as 2 pi nu by 2 pi by lambda. Okay, which is equals to lambda v, which is equals to hv by mv. So if we know that E is equals to h nu for a material particle, we can write it as E is equals to mc square. So if you correlate all these, we can get the phase velocity as mc square by mv, which is equals to c square by v. So obviously particle velocity v is less than c, therefore phase velocity is greater than c. So this is an unexpected result. From group velocity and phase velocity values, we can write velocity of group velocity and phase velocity is equals to c square. That is wavelength of is equals to c square. That is the product of group velocity and phase velocity is equals to c square. So this is what I think we discussed in the class regarding the phase velocity and group velocity. Am I right?
Yes, sir.
So please just go through this paragraph, okay, in the notes, and then try to understand. Even though not understood, just you meet me or just you call me. I'll tell you. Okay.
Yes, sir.
Yes. Next question is, derive the equation for energy of a particle confined in one-dimensional infinite well and explain energy quantization, 0-point energy, and spatial nodes. So for this question, so the same explanation for the energy part has to be derived for a particle in a box, and then you have to explain the 0-point energy. How do you explain the 0-point energy? 0-point energy is what you understand from here. See, so the behavior in the box include energy quantization. It is not possible for the particle to have an arbitrary definite energy. Okay, instead only discrete definite energy levels are allowed. So 0-point energy, the lowest possible energy level of the particle called 0-point energy, that is non-zero. Okay, and other is spatial nodes. In contrast to classical mechanics, the Schrödinger equation predicts that for some energy levels, there are nodes implying positions at which the particle can never be found. Okay, so these are the assumptions. So these are the points that are to be discussed. Okay, that are to be discussed for this question. That is, explain the energy quantization, 0-point energy, and spatial nodes. Okay, it is directly given in the. It is directly given here. Just go through these points. Okay. Okay, now, so that will give that long answer questions. So the long answer questions will be somewhat related to short answer questions also. Okay, so that is what relate quantum mechanics with classical mechanics. That is what the differences between classical mechanics and quantum mechanics. Okay, and the same maximum of the questions will be repeated in just short answer questions from the long answer questions. See here, there is a concept called Heisenberg uncertainty. This is not there in our syllabus. Okay, so just anyway, we'll discuss these questions. Okay, we'll discuss this. Okay, so the topics to be discussed once again are the energy eigenvalues and energy eigenfunctions. Okay, so that topic I will let you know. Okay, before completion of the course, I will let you know what is the energy eigenvalue and how do we write the energy eigenvalue and how do we write the energy eigenfunction. That we will do it. Okay.
Classical theory and quantum theory also.
Yeah, that question is directly given, Gadama. It is given in the question. It is given in the very first part.
You said you'll discuss it again, sir.
Okay, no problem. But you can, I think you can write it. The differences only, na. So Newton mechanics, and you have to write the differences between Newton mechanics and classical physics, classical mechanics. Sorry, Newton physics and quantum physics. So that is what, see, akkadaithe emaithe classical physics lo evaithe failures unnayo adi ikkada manam explain cheyali. Okay, I'll let you know I will let you know clearly. Okay, don't worry. So those two questions are to be discussed. Okay, so first one is the the relation. First one is to understand the differences between classical theory and the quantum theory. Okay, differences. Okay, the differences between classical theory and quantum theory. And next one is we have to understand the energy eigenfunction and energy values, right? So these are the two questions which are to be discussed, right? Am I right? Okay.
Yes, sir.
So next, if you see, what is the de Broglie's hypothesis of duality of particle waves and concept of matter waves? The same questions, away questions, ikkada repeat outu untayi in the form of short questions. Okay. If anything found difficult, then we will discuss. Okay.
Okay, sir.
So tomorrow also we'll discuss this questions, and then we'll go ahead with the second module. Okay.